So we're going to start with just a couple of terms, not because I'm going to ever quiz you on vocab, but just so we can communicate in a mathematical way and that you know what I'm talking about. So a polynomial is this big umbrella term that can either be a monomial. I know I feel like I just used a word in a definition that is part of the definition, but we'll talk about that in a second. Is either a monomial or a sum or difference of monomials. So a monomial is either a product or quotient of variables and numbers. So 3x is a monomial. X divided by 4. 2z to the third. All of those are monomials because they are just one term, things that are all just being multiplied or divided together. But a polynomial could be those added together. So 2x plus y, 2x to the third minus z to the second. So we classify them typically on how many terms they have. So if something just has one term, it is called a monomial. So 3x is one term. That 3 is being multiplied with the x. ab to the third, all of that is just being multiplied. xy over 4, all of that is just being multiplied and divided, which makes it a monomial. A binomial has two terms. So 3x we decided was all one term, but as soon as I add 1 to it, I've separated and made two separate terms. So 3x plus 1 is considered a binomial. 2z minus y is a binomial. It's got two separate terms. And a trinomial is 3. So let's see, 4x to the second is its own term. 2x is its own term. 1 is its own term. But when we smush them all together into a polynomial, when we put them in separate terms, that is considered a trinomial. There are 3 different terms. So I'm going to be using those over the next few days. And it's all just about how many terms they have. Their powers don't necessarily matter, right? 4x to the second could have been 4x to the 8th. Doesn't matter. It matters how many terms there are in the individual expression. So the base of what we're doing today, we're talking about adding and subtracting polynomials. And I want to go back to something I know you know really well. If you were just in the middle of an equation or an expression and you saw 4x plus 2x, I'm 100% confident that you would add those together to get 6x. But we've been working with these exponent rules where sometimes exponents change, and so we start kind of blurring kind of when to do which tool. And so this is what I want you to kind of consistently fall back on. If something looks like 4x plus 2x, for example, 4x to the fourth and 2x to the fourth. In the same way that you added x's with x's to get x's, here I'm adding x to the fourths with x to the fourths to still just get more x to the fourths. So notice the base, that the part that we are adding is not changing. The coefficient is because we're changing the amount we have, but not actually what we have. So even something like 4ab plus 2ab would be 6ab. So it's all about adding like terms, just like you did when you added x to x. You knew you couldn't add x to 2, right? One was a number, one was a variable. Same concept when we're working with terms that have powers. So when you see these kind of complicated expressions, notice in this first one, they've grouped together 3 terms. So I've got a trinomial adding to another trinomial. I'm looking at what can be combined. So x's can be combined with x's. That will be the most natural part because we've done that before. But now we know we can also add x to the seconds to other x to the seconds. And then that x to the third and our boring constant number 9, nothing to combine with. So they're just going to be on their own. So typically when we add, we like things to be in descending order. So descending order means that we start with the highest exponent and work our way down. So x to the third is going to come first. And then I've got negative 2x to the second and 5x to the second. So negative 2 plus 5 is 3. And remember, when you add x to the seconds to more x to the seconds, you just get x to the seconds. That exponent is not changing in any way. Negative 6x and negative 4x is negative 10x. And then we have our 9. So you'll notice that our exponents went from something to the third, to the second, to the first, to the nothing. That is descending order, where those powers are decreasing as we go along. And that's it. We decided we can only combine things that are like terms. X to the thirds aren't like terms with x to the seconds, and so we have to be finished. So I'm going to encourage you to pause your video and go ahead and work this bottom problem. I'm going to work it really quickly, but go ahead and pause it and give yourself a try first so that then you can check to see how you're doing. All right, so once you've checked that one, the only way this gets a little bit more difficult is with subtraction. And it's not more difficult in that we still add x to the seconds with x to the seconds to get other x to the seconds. But we have to be careful with our signs, because everything after your subtraction sign needs to get subtracted. That is being distributed to that second parentheses. So my preference is I actually like to just rewrite the whole problem. So this first parentheses is unchanged. Negative 4m to the second. Negative m because of that distributive property. And then actually a positive 12 because we have a negative times a negative. And at this point, now I can start finding those like terms. M's with m's. Numbers with numbers. Only one term has a power of 3. Only one term has a power of 2. Negative 1m and another negative 1m is negative 2m. And then 9 and 12 make 21. Same thing, I'm going to ask you to go ahead and pause and attempt this second one. Careful to distribute that negative first, and then start combining your like terms.